What we're going to look at here is the angle bisectors. So if you've already done the thing on perpendicular bisectors, you'll know that it just means cutting something into two equally sized pieces. So we've got an angle in here, and we can name that. We can call that angle ABC. We can put a little hat over the B because that's where the angle is centered, about point B, or we could write it as angle ABC. The important thing is that B is at the middle. Anyway, we're going to bisect that. We're going to cut that in half. Now, in this case, again, all we're going to use is a compass and a pencil. Okay, so what we're going to use a ruler as well, or a straight edge. So what we need to do is set our compass to some distance. Now, what we could do is we could set the compass just to like this, for example. Okay. But there's always small amounts of error in any measurement you make, any distance you set, there's small amounts of error. So let's imagine we have a 1 millimeter error with this. Well, if you imagine 1 millimeter is a bigger chunk of this distance than it is for this. So if you imagine the percentage error at this size, if it's 1 millimeter, is a lot bigger in proportion to this distance than it is to that. So generally, you're just better to work with bigger distances if you can. Obviously, once you get to this kind of distance with these compasses, it becomes very annoying and difficult to use. So be sensible about it. Anyway, I'm going to go round about halfway, or a little bit more than halfway in this case, and get your pointy bit. Try and get that as close to the very end, the very point of your of this angle as you can. And we're just going to do a little small arc just there, just lying on that line. Doesn't need to be long. It doesn't even need to be that big of a curve. What we're also going to do is, without changing the distance, we're going to do a similar little curve right there. Like I said, it doesn't matter where along these lines this is, because what we're going to try and do is we're trying to bisect the angle. Let me just do those lines a little bit harder so you can actually see them a bit better. Okay. What we essentially want to end up with is a line which goes exactly halfway between these. Okay. So halfway between these two. So we could kind of eyeball it, we could just guess, but it's not going to be very good if we do that. It's not going to be very accurate, whereas using our compass will let that be very, very accurate indeed, so long as we don't change the distances on the compass. So we've got those done. Now what we're going to do is we're going to do the actual bisection. It's really important that each of these is the same distance, if you remember, from B as at all points. So remember that term, equidistant, okay? The same distance from some point at all of the points on those arcs. What we can now do is we can make our compass a little bit smaller. We can change that distance right there. Now what it needs to be, again, because it's being bisected, it needs to be more than half the distance between these 2 points. So that looks about right to me. We can measure it, but you can kind of eyeball it as well. You will see quite quickly when you make a mistake that you have made a mistake. Okay, so we'll put our point as close as we can right where that arc meets the line, and all we're going to do is we're just going to draw a line, or we're going to draw an arc, I should say, not a line. So we've got our arc right there. Again, it doesn't matter if it's too big, but it does matter if it's too small. So there's our first arc. Now keep that distance the same. Do not change the setting on your compass, and what we'll do is then we'll go to the opposite side and do another arc. Top tip, actually, when you're using these, sometimes if you push hard on them, they will slip. So if you give a little tap at the top and just push it further into the paper. So you will see we've got our 2 arcs. Now you might already see what my next step is. Well, apart from grabbing a sharpened pencil. What I'm now going to do is I'm going to connect point B with the 2 points that are formed between these arcs. I'll take my pencil, my sharp pencil, set it onto just one of those points. Now what I can do is I can then bring the ruler over to that and then try to line it up with these other points here. So we've got this point and point B, and then I'm just going to draw that line right there. Now you remember I talked about error earlier on. You might see that's not exactly perfect. It's a little bit closer to this line here than it is to that line, but this is pretty good. This is an angle bisector, and if you remember one of the terms we talked about before, at all points, this is equidistant from the point, the like points on A and B. So if I am, for example, 5 centimeters, let's just move that a bit. If I am, let's say, 10 centimeters along line AB, and I'm also 10 centimeters along line BC, then I should be the exact same distance. These two should be the exact same distance, and let's look at that. So here we've got, let me see, 3.75, 3.8 centimeters. And what we should have here is, yeah, exact same distance. So what we have got is, at all points along this line, it is equidistant from a point on each of these lines of a certain length, or of a certain distance from point B. What we'll also have, because it is an angle bisector, if I measure the original angle, angle ABC, let's just get my protractor. So my original angle ABC is 10, 20, 30, 40 degrees. And let's just check that. So we can see here that, let's just call that, I don't know, X. So angle ABX is equal to 20 degrees. And angle XBC is 20 degrees. Also 20 degrees. So our angle has been bisected, cut in half. Same thing no matter what kind of angle, whether it's an acute or an obtuse angle, you won't be asked to bisect any other ones than that, not at this level anyway.